Have you ever wondered what happened after you flush? Have you ever wondered what happened after you wash your hands? Where does the water go? Sustainability of existing water resources, known as the world's most significant issue nowadays. This problem can be related to many reasons, such as poor water allocation, insufficient way of using, managing, and monitoring water resources. One of the most reliable solutions for overcome this problem is wastewater treatment. Wastewater treatment is a process used to convert wastewater, which is a water no longer needed or suitable for most of the recent use, into an effluent that can be either returned to a water cycle with minimum environment impact. Programmable logic controller, as known as PLC, is a digital computer designed for automation industrial electrochemical processes, such as petrochemical and food industry. PLC consists of two sections, which are the central process unit, known as the CPU, and input-output interface system. The CPU controls all systems activity through its processor or memory system. The memory system in the CPU is reliable for storing the available program, which also receiving status from the PLC. This process consists of many unit operations. The first unit operation is inlet screening. The main objective of this inlet screening is to remove large objects such as rock, plastic, or paper to prevent damage of downstream equipments and piping. There are two types of this unit operation. The first one is coarse screening, which is used to remove large materials from the process. And the second one is the fine screening, which is used to remove the material that can affect the process, the operation of this process, as well as the maintenance. PLC can be used to improve the wastewater treatment with its programming to control and measure the liquid level of the tank. Furthermore, in economical point of view, the good level control of solid also desirable, and excessive buildup in hoppers can be expensive to clear.
In standard wastewater treatment plant, wastewater normally has to go through fill station in order to be treated to become clean water.
The raw wastewater will first enter the inlet screening station, where solid non-biodegradable substances are removed. Then the flow will pass to a grit trap, where grit is removed to a classifier, dewatered and compact, before disposing into a skip. After settling the grit, the wastewater will flow to a forward pumping station, which will then be pumped to an aeration tank and to the clarified. Clarified wastewater will then gravitate to the tertiary filter feed pumping station for final treatment and flows to the final effluent pumping station. The tertiary filter is periodically backwashed using treated wastewater. The wash water is directed back to the forward feed pumping station. A sampler automatically collects samples of the treated effluent for analysis.
A wastewater treatment plant usually has a lot of valves and pumps installed so that the parameters of each process can be adjusted and controlled. To ensure the whole plant is in control, wastewater treatment now are typically controlled and monitored by a network of programmable logic controllers (PLC) and operator terminals.
Referring to the P&ID, PLCs are mainly programmed and used to control the activation of motor, pumps, and water level. For example, in the aeration tank, PLC is programmed to control the aeration wheel drive motor. The drive motor is started by the PLC timer if it has not operated within the set time, whereas for the tertiary filter feed sump, pumps are operated on a duty or standby basis. They are controlled by level sensor and PLC timer during a backwash cycle. When the backwash cycle is initiated for the tertiary filter, the PLC prevents the filter feed pumps from operating while the backwash cycle takes place, irrespective of level in the sump. While in the tertiary treatment filter part, A sampler automatically collects a sample of the treated wastewater in the final effluent pumping station. This sampler is controlled by the PLC timer.
Our main focus on water treatment process is only on the inlet screening process. Now this process represents the first unit process in a water treatment plant, and the objective of it is to remove large inorganic solid particles like plastic or metals. This is to prevent any damage to the equipment or any upsets to the downstream processes. There are several problem statements for this process that require some improvement. Now the first problem statement is that there is a possibility of overflow with high backwater levels, which may cause some solid buildup. The second thing is that traditional manual controls is less reliable, susceptible to human fault, which gives a higher risk of process downtime, hence profit loss for the company. This also means that there is a higher labor cost for cleaning and maintaining the process. Now, these process upsets may come from two causes. The first is that there is a high amount of debris in the wastewater, which may cause inconsistent water level buildups in the machinery. The second one is that lower or higher velocity flow through the screen rack may cause inconsistent processes. Now, the main recommendation for this is to install a programmable logic controller, aka PLC, to replace manual operation with water level sensors and flow sensors as input modules into the PLC for desired water and level control. For the PLC systems, Sematic S7300 PLC is selected based on process criteria and also its advantages. Several main advantages that this system provides includes cost effectiveness, user-friendly data, higher accurate in process control, and it has fast and dynamic response to any changes to the system. The system is also high shock and vibration resistance, which is suitable for the inlet screening process of wastewater sludge. Water level and flow sensors recommendation and selection are based on criteria chart for level measurement selector from Siemens, which can be seen here. Ultrasonic level measurement sensors is preferred based on the following criteria for the screening process: that the flow is continuous with turbulent fluid flowing through, the flow is also high in viscosity, and it also contains solid granules that are flowing through it that has a diameter bigger than 25 millimeters. Based on the guidance of the chart, Siemens Citroen's LUT400 sensor is chosen for the process. It also comes with advanced pump, alarm, flow control features and energy-saving algorithms. For flow sensors, the MAG 5100W is chosen based on its specific application for all wastewater applications in treatment plants. Now for the next part, I'll be talking on how the system of sensors and PLC would come together to optimize the process. Ultrasonic level indicator transmits ultrasonic wave towards the liquid surface, and it is reflected back where the receiver detects the returning signal. Time duration between the transmission and detection of the signal measures the level of water in the process. Liquid level measurement signals are then sent to a programmable logic controller, also known as PLC, as the input module, with a set point of water level that has been pre-programmed in PLC. The control system then determines the required signal to the output module, such as devices as valves, alarms and pumps. This then runs the action for optimizing the process based on the instruction signals sent from the pre-programmed PLC.
Advantage of using PLC in wastewater treatments are PLCs are very inexpensive. At low end of this technology, PLC can be easily be purchased for less than $1,000. It is also easy to program, operate, maintain and repair. Individual PLCs can be used in singular, dedicated fashion to monitor and control specific tasks. If one PLC system failed, the loss would not disrupt the operation of the second PLC. Multiple sensors monitoring and correlation. Unlike dedicated and microprocessor controller, which can be usually accept only one form of input signal voltage and amperage, PLCs can be easily accept or diverge range of sensory inputs. And PLCs also allows for fast and easy online changes in relay ladder logic to meet the changing needs of the process. There are only a few disadvantages of using PLC in wastewater. The power line is very bad channel for communication, mainly because of interference and signal attenuation. When there is problem occurs in the treatment, the hold-up time is very long.
In conclusion, PLC system is widely used in a lot of plants, especially wastewater treatment process. However, there are problems arise in inlet screening process. Schematic S7300 PLC system is selected to replace manual operation as it is cost-effective and high accuracy. PLC system can implement with water level sensor and flow sensor to prevent high backwater levels and low velocity, which leads to solid build-up. For ultrasonic level sensor, Siemens Citrus LUT400 is chosen as it met all critical conditions for inlet screening. Flow sensor MAC 5100W is chosen based on its specific application on wastewater treatment. The advantages are low cost as PLC is inexpensive and it accepts a diverse range of sensory inputs. PLC system can stand alone for functioning too. Overall, PLC system can provide companies with various improvements that can improve cost and process efficiency. Thank you.